it's 64 plus 225, and that is equal to 289. So hypotenuse square is 289. Hypotenuse will be square root of 289, and that is equal to 17. Hypotenuse equal to 17. So we got this value of hypotenuse, and it is 17. Let's calculate this sine and this sec now. See, for a triangle like this is A, B, and C. This perpendicular was 8 and base was 15, and this we just calculated is 17. This is 90 over here. Now we have to find this sine of A. Sine of A. As all of you know, sine is perpendicular over hypotenuse. So what is perpendicular for this angle? It's just side opposite to it. It's 8 over this hypotenuse. Hypotenuse is 17. This is sine of A. Similarly, secant of A. It is just, as you know, secant is just inverse of cos. Cos is base over hypotenuse. So this secant will be hypotenuse over base. Now hypotenuse is 17 and this base is 15. So this is the value of secant or sec A, 17 over 15. So this is all about question number 4. Let's move to question number 5 now. See, it is secant, or we can say sec theta, is equal to 13 over 12. Evaluate all other trigonometric ratios. All other trigonometric ratios, see, it's sec is given here. We have to calculate sine, cos, tan, cosec. Sec is given, so cot. This is sine, cos, tan. We have to calculate all these 5 trigonometric ratios. See, let's draw a right angle triangle like this. These all questions are similar to each other. A, this is A, this is B, and this is C. This is 90 degrees here, and this we consider as our angle. This theta, we take this theta as angle A. This theta is just an angle, so we represent this theta by this our angle A. So side opposite to it, this is our perpendicular, and adjacent side it's base, and this side which remains there, it is hypotenuse. So this secant theta is given, or sec theta we can say, it's 13 over 12. Now this sec, it's just inverse of cos, and cos theta, as we know, cos theta equal to base over hypotenuse. So what will be the value of this sec? It will be hypotenuse over base, just invert it. So hypotenuse over base is given, and that is 13 over 12. So we can take this hypotenuse as our 13 and this base as 12. So this hypotenuse is 13 and this base is 12. Let's calculate the perpendicular now by Pythagorean theorem. See, by PT, Pythagorean theorem, in this triangle ABC, we know hypotenuse square, it's equal to base square plus perpendicular square. Hypotenuse it's given, it is 13. So 13 square is equal to base square, base is 12. So 12 square plus this perpendicular square. This perpendicular we don't know, and this is BC. So BC square we have to calculate. So this 13 square, let me write it here. This 13 square is 169. It is equal to 12 square, and 12 square is 144, plus this BC square. See, 169, take this 144 to this side. It will be 169 minus 144. That is equal to BC square. This 169 minus 144, it is 25. So BC square is 25. Therefore BC, this will be root to this side. So root of 25 is 5. So we got the value of this BC. That means perpendicular is 5 centimeter. Now we got all the 3 sides of this triangle. Now let's calculate the trigonometric ratios. See, first it's sine of A, or we can say theta, because we represent this angle A now by theta. It's perpendicular by hypotenuse. Similarly, cos of theta, it will be base over hypotenuse. And similarly, all the five trigonometric ratios you can calculate. I hope it's clear, and this is left hand exercise for you to calculate all these values, because these all questions are similar to each other. Let's take this question number 6. Its angle A and angle B are acute, and cos A and cos A is equal to cos B. Then show that angle A equal to angle B. See what is given. Angle A, angle B are acute. Acute means they are less than 90 degrees. See, and cos of A is equal to cos of B. Then show that, what we have to show, angle A is equal to angle B. Okay. See, let's draw true right angle triangles like this. And let's take this right angle over here, and this is our angle A, this is C. And let's take similar triangle like this. This is P. No, actually we have to prove like this. This is A, this take C, and let's take this D, and let's take this B, because we have to prove this angle equal to this angle, and this as P and this as Q. This is right angled here, 90 here, and this is right angled here. See, as this is given, angle A, angle B are acute, and cos A is equal to cos B. Now let's calculate cos for this A first. Side opposite to this, it's perpendicular, adjacent, this is base, and this side, this is hypotenuse. So what is the value for this cos of A? Cos of A will be equal to base over hypotenuse. So what is base for this? It is this AC, and hypotenuse, it's this AD. Now let's calculate cos of B here. Cos of B. So side opposite to this is our perpendicular, this is base, and this one will be hypotenuse. So this cos of B, it's perpendicular, that means this QP, base, actually cos theta is base over hypotenuse. So what is base? This is this BP. And what is hypotenuse? Hypotenuse is this QB. See, we got two values. This is for cos of A, and this is for cos of B. As it is given, cos of A is equal to cos of B. That means this AC by AD will be equal to BP by QB. That means this AC by AD, it will be equal to BP by QB. See, let us equate them to K. For example, this ratio by this ratio, this ratio is equal to this ratio, and let's say this is equal to K. That means this ratio is equal to K. Also, this ratio equal to K. First, let's equate this. This is AC by AD. It's equal to K. That means AC will be K times AD. Let's take this as equation 1 and equate this now, this ratio to K. This will be BP by QB. It's equal to K. That means take this QB to this side. This is BP is equal to K times QB. Let's denote this as equation 2. See, I'll write this as here AC is equal to K times AD, and this BP, it is equal to K times QB. Let's write them here. Now, this is our hypotenuse. Now, this perpendicular and this perpendicular in this triangle. See, let's first apply Pythagorean theorem to this side. By PT in triangle ACD, ACD, this hypotenuse AD square will be equal to AC square, that means base square, plus this perpendicular DC square. See, let's take this AC to this side. It's AD square. This will be here minus AC. AC square, it's equal to DC square. See, this square will come as root to this side. So AD square minus AC square square root, it's equal to DC. And similarly, let's apply PT to this triangle now. So from this triangle, this hypotenuse QB square, it will be equal to this BP square plus this QP square. Hypotenuse square is equal to base square plus this perpendicular square. Let's get this perpendicular from here also. It's QB square, take this to this side, minus BP square, it is equal to QP square. This square will be as root over this side. It's QB square minus BP square whole square root is equal to QP. See, we got these two equations. This QP and one for this DC. Let's divide this equation. Let's denote this as equation A and this by B. See, I will. Let's divide equation A by equation B. That means we are doing this DC by this QP. Now, what is the value for this DC? It's this square root of AD square minus AC square divided by this, because this QP is equal to this. This is QB square minus BP square. Now, look at these equations. This AC, it's equal to K times AD. This AC, it's equal to K times AD. So, we can write like this AD square. Instead of this AC, we can write K times AD. So, it's K times AD square divided by. For this QB and this BP from here, it's equal to K times QB. So it is divided by square root of QB square minus, instead of this BP, we can write K times QB square. See, now this is square root of AD square minus, this is K into AD. So square will distribute to both. It's K square AD square. And from this, it's QB square square root here. It's QB minus this K square QB square. Let's erase this now. See, we can take this AD common. This AD. It will be like this. AD square. So it is 1 here minus K square divided by this QB, because when we multiply this AD square with 1, it will be AD square, and when we will multiply this AD with K square, it will be K square times AD square. Similarly for this, take this QB square common. So here it's left 1, because QB square into 1 is QB minus K square. So this K square into this QB square will be K square into QB square. Now see, this and this, it will go because it's same multiplied over 1 minus K square here and 1 minus K square here. See, I will explain this how. It's root of AD square, and we can, these are in multiplication, we can write it like this, square root of 1 minus K square, separate like this. Similarly from here, it's QB square multiplied by this square root of 1 minus K square. Now this and this will go. So we are left with square root of AD square over square root of QB square. Now it's square and root, this will go, this square and root will go. It's equal to, basically we have divided this DC by this QP. Now see, what is the conclusion? We got AD by QB. It's equal to DC by DC by QP. Now this AD by QB, see what is this? It is AD by QB. Basically, see, let's move this here. This is AC, it's equal to K times AD, or we can take this AD back here. This is AC by AD, it's equal to K. Similarly from this, it's BP equal to K times QB, or BP by QB, it's equal to K. Basically, what do I mean to say? This AC by AD, it's equal to this BP by QB, because both are equal to K. See, this AC by AD, it's equal to BP by QB. Now see what we got here. We got AD by QB. So take this AD here and this BP here. I mean, it's AC. Take this BP here. It's BP is equal to, take this AD to that side. AD divided by its QB here. This is equal to K. Now the ratio which we just calculated, this DC by QP, it's also equal to these. So it's also equal to K. So we conclude like this. This AD by QB, it's equal to DC by QP, it's equal to K. That means this AC by this BP, it's equal to AD by this QB, it's equal to this DC by this QP. What is this? Isn't this a criteria for similar triangles? SSS criteria. That means this triangle is just similar to this triangle. See, we concluded that this triangle, these two triangles, triangle ABC is just similar to triangle BQP. That means angle A should be angle 2 is equal to angle B, because this is similar triangle. These are similar triangles, and all the angles in similar triangles are equal. Basically, in this question, it's too lengthy question. So we concluded, this conclusion is this: we have to prove this triangle is just similar to this triangle, and from this we can conclude that this angle A is equal to angle B, which we just need to prove. Angle A is equal to angle B. Let's move to next question, and that is question number 7, and it's like this: cot of theta, it's equal to 7/8, and evaluate. What do you have to evaluate? First part is 1 plus sine of theta multiply by 1 minus sine of theta divided by 1 plus cos of theta 1 minus cos of theta. And second part is, write it here, second part, it is cot square theta. Cot square theta, we have to get this. See, now let's draw a right angle triangle like this. This is our A, this is B, and this is C. This theta, we are representing it by angle A. So angle A is our theta, angle A is our theta. So this side, just opposite to it, this is our perpendicular, this is base, and this is hypotenuse. Now cot theta is given. Cot theta, it is just inverse of tan theta. Tan theta is perpendicular by base, so this cot theta will be base over perpendicular. So this cot theta is base over perpendicular, and it is equal to 7/8. So we can take this 7 as our base and this 8 as our perpendicular. See, so this base is equal to 7 and this perpendicular, it's equal to 8. First calculate this hypotenuse. So by PT in right angled triangle ABC, this hypotenuse square, it's equal to base square plus perpendicular square. This base is given as 7, so it's 7 square, plus this perpendicular square, it's 8, so 8 square, it's equal to our hypotenuse square. See, hypotenuse square is equal to 7 square is 49, plus this, it's 8 square is 64. Now hypotenuse, it's 64 plus, I think it's 113. 113. Hypotenuse square is 113. So hypotenuse will be square root of 113. So we calculated this hypotenuse, and hypotenuse is square root of 113. See, now in this part, see, look at this. We have to use sine theta and cos theta here. Now first calculate the sine theta. Sine of theta from here. Sine is perpendicular over hypotenuse. What is perpendicular? Perpendicular is 8. And what is hypotenuse? Hypotenuse is this root 113. So this is our sine theta. And let's calculate this cos of theta. This cos of theta. See, cos is base over hypotenuse. So what is base for this theta? It's this 7. So it is 7 over root 113. We calculated both the ratios, sine as well as cos. sine theta is perpendicular 8 over root 113, and cos of theta is base, that means root 7 by 113. See, let's look at this now. It's 1 plus sine theta. Instead of sine theta, we can write this 8 over root of 113 multiply by 1 minus sine theta, that means same 8 over root 113 divided by 1 plus cos theta, that means 1 plus cos theta, it's 7 over root 113 multiply by 1 minus cos theta, that means 1 minus cos theta, it's 7 over root 113. See, now these are rational numbers. When anything is not divided, it's always 1. So let's add these rational numbers. I hope you know. Basically, we multiply this with this with this, and this with this. First multiply these two. So it will be fraction like this. Root 113 into 1 is root of 113. Root 113 multiplied by 1, it's root of 113 plus 8 multiplied by 1, it's 8 multiplied by this, it's 1 minus 8, so same, it's like this. When anything is not here, it's always 1. Root 113 into 1, it's root of 113. Root 113 into 1, it's root of 113 minus 8 into 1, it's 8. And what is in divide? It is 1 plus, see, same, root 113 here, 7 here, and these two multiplication. It's root 113 into 1, so it's root of 113. Root 113 into 1, it's root of 113 plus 7 into 1, it's 7. Same goes here, it's root 113 first with this one, so it's root of 113, it's 3 here. Root 113 into 1, it's root of 113. Now 7 into this one, in between it's minus. 7 into 1 is 7. See, this root 113, it's here, and I mean it's in numerator as well as in denominator, so in both it will get cancelled. So we are left with this root 113 plus 8 multiplied by root 113 minus 8 divided by root 113 plus 7 multiplied by root 113 minus 7. See, let's represent this root 113 by A and this 8 by B. So what is written over here? Basically it is A plus B, and same here it's A and this is B. So what is written over here? It's multiply with A minus B. So basically it's an identity, A plus B into A minus B. It's A square minus B square. Same, if this is A, this is B. This is also A, this is also B. So it's written here A plus B into A minus B. So it's also equal to A square minus B square. So by this identity, which we just discussed, it is root 113 square minus 8 square. That means it is root of 113 square. A plus B into A minus B, that's equal to A square minus B is here 8 square divided by root 113, that means A plus B into A minus B, that is root 113, that means A square minus B, here B is 7, that is 7 square. See, this square and this root will go here also. This square and this root will go. It's left. We are left with only 113 minus this 8 square. It's 64 divided by root 113. This also it's gone here. Root it's 113 minus 7 square. It's 49. Now it's left to you calculate this and this. That will be your answer for this. Now it's second part of this question also. It's cot square theta, and I think we are given with this cot. Yes, cot theta we are given with 7 by 8. So only cot. Now we have to calculate cot square of theta. So it is 7 by 8 whole square, because cot square theta, it is cot theta whole square. This is one and the same thing. So 7 square, this square will be distributed this and this. This is 7 square by 8 square. 7 square is 49 and 8 square is 64. This is your cot square theta.